Okay, so what we talked about last time, just to recap since you had the weekend in between, right? We talked about relations and functions and their differences. Everybody remember? What's one difference between a relation and a function? It has to do with the domain and range, but what specifically? Does anyone remember? I think I heard it, but I can't hear it loud enough.
One only goes to one.
It only goes to one, but what only goes to one?
Domain.
The domain only goes to one thing, yes. So when we have our elements, right, they only have one arrow coming out. Two arrows or more than one makes it just a relation, right? Okay. So, and then we talked about the vertical line test, right? And just how we can look at the different graphs and see if it overlaps or if our marker, or, well, pencil in your case most likely, going across the graph hits the function or hits the line more than once or hits the points, right? Or they're over top of each other. Okay, so now we want to talk about just kind of, instead of looking at a graph, if we can look at just different equations and see if they're functions or not, okay? There's also, I know some of you did those last night in the lab. So just some different ones. If we have x plus y equals 7, what do we think we should do to see if this kind of would have the right setup? Any ideas? I told one of you yesterday. So do you still remember? Try to find one of the variables. How? What do you mean by that? Subtracting x. So solving for one of the variables. Okay. So you're saying solve it for y basically. So by subtracting the x to the other side, so then we get y equals negative x plus 7. So did that help us?
Yes.
Why yes?
So now we can plug in for y.
Okay. Why would we want to plug in for y though? Okay. So that would be finding the intercepts. So let's look at this. We want to see if this function can be written basically as y, that's generally our range variable, right? Is y a function of x? Can we write it singularly basically? Y equals this set thing, right? Does that make sense? No. No, okay. So y just equals negative x plus 7. That's all it is, right? Maybe it'll make sense if we have x plus y squared equals 7. Let's try to solve this for y. What would we do here? Subtract x again. It didn't really change too much, just the y squared. So we still have negative x plus 7, but it's not just y. How do we get it to be just y? Take the square root of both sides. But what happens when we take the square root of this side? What do we have in front? The plus or minus. So does y equal one thing now? No. So it's going into two places, right? Well,
Not a function.
you don't get it? Okay. What part's confusing? We're trying to find, basically, can we solve for y and have it equal just one thing? Right? Just like any regular old function. If we wanted to write this out, we would have to say that y is equal to the positive portion of the square root and y is equal to the negative portion of the square root. Okay? So y doesn't just equal one of these, it equals both of them for this function, right? So we couldn't solve for y and have a singular thing over here. This one, we just solved and it was exactly just that. Does that kind of make sense? Better? Okay, so it's all about, can we get y on its own and not have a plus or minus, usually, is the thing that we're looking for, that can differentiate the two pieces. Yes? Better? Okay, let's do some more. So, if we have x squared plus y equals 7. So before we had no squares, then we had a squared on the y, now we have a squared on the x. Do we care? Did that do anything bad? Because we can just subtract it over and we still get y equals negative x squared plus 7. It's just exactly like this one, y equals one thing, right? So is it a function? Can we write y as a function of x?
Yes.
Yes. Okay, so that one's good. Okay, what about x times y squared equals 7? So we took out the plus. Now it's one term.
Divide.
We can divide by x, that's how we would start solving. So y squared is equal to 7 over x. Then what? Oh, we take the square root. What do we know already when that happens? We know that's going to give us the plus or minus. So already we know this one's no good, right? It's not a function of x because it has those two pieces kind of thing. Yes? You saw that again? Question?
So whenever there's an exponent, does that mean it's not a function?
It's a good question. What if we had xy cubed equals 7? What happens then? We divide by x again. What now? We take the cube root. When we take the cube root, or an odd root, do we get the plus or minus like we do on even roots? Why not? Okay. You know no, but why not? Because if we take the cube root of negative 8, what is that? Negative 2, right? Because negative 2 times negative 2 times negative 2 is still negative 8. The negative doesn't go away, kind of thing. It's still there because it's an odd power. So when this happens, it's just y equals the cube root of 7 over x. So it's not the fact that it's an exponent, it's the fact that it's a cube. Even is what we were going for to go back to your question originally. Does that make sense? Here and no? Okay, they're all yeses? Yes? Okay. What was your question then before? Oh, well, there we go. Okay. All right, then. So, what if we have them both squared? Does it change? Because before we had just y, then we did just x, and then we multiplied them. But does it matter if they both are? Yeah, because it matters if the y is still squared, right? We don't really care what's happening to the x for this question, right? So we just look at the y term and try to solve again. And we know we're going to end up with the plus or minus again, right? Okay. Yes? The question was asking for, can we write the equation as y as a function of x, basically. Can we write it as y as a function of x? Okay? There's multiple of those questions in the homework. All right, so now function notation. So function notation is when we have f of x generally instead of y. All right, so they mean really the same thing. I always like to think about it as it's just a way of having all the information together. So if we have y and we plug in, let's just do something easy. If we plug in x equals 1, well, we plug it in, we get 1 plus 1, so then y equals 2. Well, where'd that y equals 2 come from? We have to go back up to where we plugged in to see that we plugged in x equals 1. Function notation is handy, and then it keeps it all right there for us. So with function notation, we would have f of x, let's just go back to my same example, equals x plus 1 instead of y, right? It just replaces. So then when we plug in x equals 1, we do it in the function, right? And over here in the f of x. So f of 1 now is 1 plus 1, or f of 1 is 2. So we see right here the difference. Here we just know that our y value is 2 from something. Here we see, oh, well, we plugged in 1, we got 2. Right? It's a good consolidation so we don't get lost in the problem of what we just did. Okay? So let's do some examples of this, of using function notation. So if we have f of x equals 4 minus x squared, and we want to find some different values. Okay, so let's first find, well, f of 2. What do? We plug in x equals 2. So we get 4 minus 2 squared, right? Wherever the x is, you're replacing it with that value, or whatever is inside here. Okay, so then we just solve, right? We simplify. What do we get? 4 minus 4 is equal to 0. So f of 2 equals 0. How could we write that as a point? An ordered pair? 2, 0. Because that's the x and that's the y, right? Because as well as saying instead of y, you can say that f of x is y or equals y. Right? So that is the y value, whatever it equals at the end. So then what if we did f of negative 3? What do? Plug it in. Same thing. Doesn't matter that it's negative, right? We still plug it in the same way. We get 4 minus, now this is where you have to be careful, still write the parentheses, because, right, we're squaring specifically a negative number this time. This time, we didn't necessarily need the parentheses. It helps to visualize it that you're just replacing the x, but this time we need them, right? Because otherwise, the negative goes away, kind of thing. We don't want it to disappear on us. So, let's simplify. We get 4 minus 9, because negative 3 squared is positive. Okay? Then just subtract, so it's negative 5. So what's the ordered pair this time? Negative 3, negative 5. Okay, let's do another one. So this time, now to demonstrate the fact, right, it doesn't matter what we're plugging in, okay? You can have anything. We can have a shape. We can have a positive. We can have a negative. We can have a multi-term. Anything that we put inside of f of, right, inside those parentheses, we're replacing x. So literally this would just be, any guesses? Same function. Minus star squared. Yep. Well, since we don't know what star squared is, that's the answer. It's 4 minus star squared, right? Okay. What if then we had more than just one thing, right? What if we had x plus 1? What would we do here? Replace the x with x plus 1. So we have 4 minus, parentheses, very important again here, x plus 1 squared. And then simplify. Now we actually can, right? So 4 minus, we have x plus 1 times x plus 1, right? Since it was squared. So that means we can FOIL. What do we get? X squared plus 2x by combining the outer inner plus 1. And then what? Distribute the negative to every term. So to the x squared, to the 2x, and to the 1. So what do we get? Minus x squared, minus 2x, minus 1. Are we done? No, one more step. You can sort it if you want, or you could leave it kind of thing and just combine like terms. It doesn't really matter. Just make sure that if you put the x squared first, don't lose its negative, right? Okay, so how do we want to write it out? Negative x squared, okay. Minus 2x plus 3. And this is f of x plus 1. It also helps that if you bring that down. Okay? Questions on that one? Make sense? We're still doing function notation. All right. However, what if we have a slightly different function and that it has our variable in multiple places? So if we have, let's use even, it doesn't have to be f of x, it could be g of x. So our function, the equation that we're kind of defining here will be x squared plus 2x. And let's find g of negative 1. So what do we have? Negative 1 squared. Like that?
No.
No? What's wrong with it? Needs parentheses. Plus 2 times negative 1 equals 1, because negative 1 times negative 1 is positive 1. Minus 2. So g of negative 1 is equal to negative 1. So what's the point? Negative 1, negative 1. We didn't do anything different even though we added a variable, right? Even though it's in multiple places, every time you see the variable, every time you see x, you just replace with whatever was in here, whatever the value is, or term, okay? You don't also have to use x, you could use t's, or anything really. We could use star as our variable, okay? Any questions on function notation? No? We're good? You think we can replicate it? Okay, so now, who can remember what a polynomial is?
Something plus something plus something.
Okay, something with multiple terms. Possibly, doesn't necessarily have to, but that's generally what we see when we say polynomial. Okay. Actually, we can't have an x in the bottom for a polynomial, right? That's a rational function. Those are the two that we studied together though, so it can be easy to confuse them. Okay. Any other ideas? What it means to be a polynomial? Something to do with the degrees. Doesn't have to have a squared term. It could be linear. Okay, let's remember. So, polynomial is no roots, no non-negative integer degrees. So, f of x equals the square root of x plus 2. Is that a polynomial? No, that is a root function. Okay, what about g of x equals x to the 0.7 plus 5? What about that? It's not an integer degree, so this would be not a polynomial, right? Okay, then what about h of x equals 1 over x?
No.
No, what is it?
Rational.
Rational, yes. So we've done no's so far. What about j of x equals x plus 5? Yes, that is a polynomial. I could say squared, I could say cubed, right? I could add more terms, or I could just leave it at 1. Any of those are polynomials, yes. So, no roots on the x and non-negative integer degrees. So, the degree, the power, right, has to be greater than or equal to 0 and be an integer. Right? Okay? Everybody could?
You said the last two, what was the h of x?
This is rational.
Yeah. So the first two is not possible.
This is a root function. Okay? Technically, that could be rooted. We're not going to get into that. Okay. So, now, specifically, what made this rational?
The x on the bottom.
The x in the bottom. So there has to be a variable in the bottom somewhere, right? And not in a root. Right? Okay. So, if we're given this equation, is it rational? Yes. Why? The top is polynomial, and the bottom is polynomial with x, right? There has to be a variable there. Yes?
Wait, what did you say?
Top is a polynomial,
Yeah.
bottom is a polynomial with a variable.
So that's irrational.
That's a rational. So with this rational function, we want to find the domain.
You said it was rational or irrational?
Rational. Yeah, we don't talk about irrational functions. So, we want to find the domain of this function. It's much easier to talk about what's bad than what's good, okay? What would be bad to plug in for x, for the domain for this function? Why? because it would be 0 on the bottom. So anytime you have a rational function, you want to figure out what would make the bottom 0, right? So you can literally take the bottom and say it can't equal 0 and solve it, right? So if we solve this, like you said, we would get x can't equal 2. How do we take just 2 out of the domain, right? So if we think of any other number but 2, we can plug it in, right? Because the top is good with whatever, the bottom is good with anything other than 2. So basically we have the number line with just a hole at 2, right? How do we write that in interval notation? Just 2 to infinity? Also the other side. So then, what's the other piece? And how do we connect them? Can we write it like this though?
No.
Why not?
It's standstill.
It's backwards. Why is it backwards? We have to go from negative infinity to positive infinity. I saw this happen a couple times, that's why I did it that way. So we have to do negative infinity to 2, close, open, 2 to infinity. And why are they all parentheses? Well, it's always parentheses on infinities, right? Then we just can't equal 2. So it's like we just pulled 2 out of the domain, right? We can get real close to it, below it, and then we start like right after 2. Okay? Does that make sense?
Wait, so this is the answer to all of that?
This is the domain. So that is the domain of this function. Okay?
So it's just whatever makes the bottom equal 0.
Yes, find whatever makes the bottom equal 0 when it's a rational function. Okay? Any other questions on this one? No? Okay. So then, what about not a rational? What if we just have a regular old polynomial? What if we have this function? And we want to, well, I already said it was a polynomial, so I can't ask that question. But what if we want to know the domain? Is there anything we can't plug into a polynomial? Why not? Well, there's nothing that makes bad things happen, right? Can't make a 0 in the denominator. You can't take a root of a negative, right? Those are the kind of the bad things we look for. Okay, so what's the domain? Everything. All real numbers. How do we write that? Exactly. Just everything, right? Okay, so I can fit one more. What about if we have that root function that we've had before? So let's make it g of x equals, we'll just do what we said, square root of x plus 2. What is bad about a root? So bad before with rational was we can't have the bottom be 0. What's bad about a root? Can't be negative inside. Why not? You can't take the square root of a negative? What if it was not a square? What if it was a fourth root?
Same thing.
Same thing. What about third root? That's fine, right? So it's only, again, even that give us the issue with negatives underneath. So on this one, we set the bottom equal to 0, right? To say, okay, that's the issue. What are we saying the issue is on this one? Can't be negative. So what does it have to be? Greater than or equal to 0. Because 0 is good. 0 is not negative, right? You gotta include him with the positives. So x plus 2 has to be greater than or equal to 0. And then we solve, right? So then we get x is greater than or equal to negative 2. Because we didn't multiply or divide by negative, right? So we don't have to flip. How do we write that as in interval notation for the domain? Bracket, negative 2 to infinity. How could we check that? Plug in something, right? Check the negative 2. If we plug in negative 2, what do we get? 0. That was the whole goal, why we said or equal to 0, right? What about something else? Let's pick something. 5, okay. We plug in 5. 5 plus 2, 7. We don't know what it is, but we can take the square root of 7, right? So those are valid. We just picked a random number. So that's a good indication that that's a good section for the domain, right? Okay, questions on those? Anything? No? No one made sense? Okay. All right, so if we kind of recap here on our different domain kind of questions. If we kind of have polynomials, which are what again? No roots? Non-negative integer degrees. Okay. So, if it's a polynomial, does anything affect the domain? Is there anything bad there? Nope. No. So, what's the domain? All real numbers. What about then rational? What is a rational function? There's variable in the denominator, and the top and the bottom are both polynomials. Okay, so what's bad about for the domain of a rational function? Don't make what 0? The denominator. So set the denominator equal to 0, and that's bad, right? So it can't equal 0, essentially, is what we're saying. So whatever that value is, so i.e. x equals a, right? So just like we did on the other one, that would be negative infinity to whatever that value is, and then a to infinity joined up, right? Okay, then there's the third one we just did, root functions. So there's kind of two pieces to this one, right? So if the root kind of degree, right, the power of the root is odd, is anything bad there? If it's in the numerator, it's all good. So if the roots function, right, the piece is in the numerator, then odd is all good, right? It's again negative infinity to infinity. Okay, then the other option would be if it's an even power, we set, what do we do for this one?
All real numbers.
Not all real numbers for even power, but what do we do on that one?
Greater than 0.
The inside, right? So inside has to be greater than or equal to 0. Okay, and then whatever that is conjoined and going in the correct direction. I can't really write that one out like I did this one, because it could go from negative infinity to the number or the number to infinity. It could go either way. Okay, what happens if the root's in the denominator? So this is like just a special thing to remember. If it's in the denominator, it has to be greater than or equal, but can it be equal, really? No. So you have to think about, oh, it's kind of like a rational function on this one here. It also can't be 0, okay? That's just like a special one. Any questions on anything there? No, we're good? We can replicate this? So if I give you one to think about for a second on your own, you can figure out the domain? We'll try? Okay, that's all I can ask. So if I give you h of x equals x squared plus 7 over x squared plus 5x plus 4. What would the domain be? So think about it. It is a rational. That is the first kind of idea to think about. What type of function do we have? So then what do we care about? That's the next thought.
Can't be 0.
So then, I'm sorry? We foil with the denominator, yep. We foil it, unfoil it, we factor. Okay, so we figured out that it's rational, and that tells us that the issue comes from the denominator. So what do we do with that now? We know what the issue is.
Factor.
We factor it. So how does this factor? Because we can look at 4 and say we have 1 and 4 and 2 and 2. It's plus, so that means add them. Well, 2 and 2 don't make 5, so it has to be 1 and 4. So that means it factors into x and 1 and x and 4. What are the signs? Both positive because it's plus 5. So plus and plus. Now what? Make them equal to 0. So, or think about them as not being able to equal 0, essentially. Okay, so how do we do that? Separately, yep. So x plus 1 can't equal 0, and x plus 4 can't equal 0. So always remember that you're finding what's bad. You're not finding the answer, right? There's another step after. So that means x cannot equal -1, and it also can't equal -4. So how do we write that? Negative infinity to -4, because that's the lower one. Remember to go in numerical order. And then u -4, -1, because we just restarted right after we pulled out the -4 and went to the next bad thing, right? The next pull out number. So then what? -1 to positive infinity. So we see here we go from negative infinity to infinity with -4 pulled out and -1 pulled out. Okay? That would be your domain on that one. Questions? We're good? We saw how it works? Yes?
What if you have x to the one that you put on the board, x to 0.7 plus 5?
Mm-hmm.
What if you have that one? So what would you do?
We don't see ones like that. So you're good. Really, it's a root function that we could rewrite, but we don't see them as decimals. Okay? Yeah.
So every time there's a polynomial, it's just negative infinity.
Well, think of a polynomial. Just any polynomial. X. Anything with X kind of thing, right? X cubed. Is there anything we can't plug into that? No, it's all good. X to the 10th plus 7x to the 9th plus, right? I could go on. Anything like that. What we're doing with the domain here is thinking what we can't plug in. Anything like that we can plug in. It could get really ugly, right? Really big or really small, but it's still okay. We can still plug it in. We can do it. Yeah, that's what we're caring about here. It's what can we plug in? Or as we said, is it's easier to think about what can't we plug in. Okay? All right, so that's the end of 3.1. All right, but remember there is a quiz tomorrow on what sections? The two before, which are 2.3 and 2.4, which are about what things? So we have slope and just lines in general, right? So line, slope, finding the equation. What are the three different forms of the equation? Yep, and we remember that standard form is the kind of yucky one that we don't really like, and it can't have what in it? Negative x and fractions. Oh, right? Right? You gotta multiply by the denominator. And then parallel and perpendicular. Alright? Remember, those are due tonight for the quiz. You have to be at 95. Have a good night. I'll see you tomorrow. Basically, I'm going to like alien and like so when there's not really many people here, as a like we're here kind of thing. Yeah, so I won't do it every day. So then we will not this Thursday, right? So take my notes for 3.2. Let me pause this.